Unit 16 Groove Welds. Groove welds are made in the space between two sections of metal. With the exception of the square groove, a flare groove, and flare groove joints, one or more of the members being joined is prepared by removing metal to form a V, J, or U-shaped trowel. This joint preparation provides for deeper or full penetration of the weld into the joint and provides clearance for the electrode. Burning, grinding, arc gouging, chiseling, or machining removes the metal. Root opening, groove angle, and bevel angle. It is important to be familiar with the common terms associated with groove joints and the preparation of the groove welds. The root opening is the gap at the joint root. The joint root refers to the part of the joint to be welded where the members align closest to each other. The root opening is used to provide access to the joint for the electrode and improved weld penetration. When additional clearance or penetration is needed for thicker material, an angle is placed on the edge of the material. A groove angle is the total angle formed between the groove face on one workpiece and the groove face on another workpiece. The groove face is the joint member surface included in the groove. A bevel angle is the angle formed between the bevel of one piece and a plane perpendicular to the surface of the piece. The angle may be placed on one side of the joint as with a single bevel groove, or the angle may be placed on both sides as in a V-groove. A V-groove weld applied to the joint in figure 16.2 is shown in 16.3. Also shown in the welding symbol, note that the distance specified for the root opening, 0.06, is shown inside the groove weld symbol, and the groove angle information, 60 degrees, is placed outside the weld symbol. As with fillet welds, dimensions for groove welds are shown on the same side of the reference line as the welding symbol. Preparation size and effective throat of groove welds. The effective throat is the minimum distance minus any convexity between the weld root and the face of the weld. It describes the weld size or penetration. See figure 16-4. When specified for a weld, the effective throat is shown in parentheses to the left of the weld symbol, as shown in figure 16-4. It appears to be the right of the depth of the bevel. The depth of bevel indicates the depth of penetration for preparing the joint. The effective throat of a groove weld is specified when the weld extends only partially through the members being joined. Complete joint penetration is indicated when no dimension is given on the welding symbol for a single groove or a symmetrical double groove weld. Figure 16.5 illustrates complete weld penetration for a double groove joint. A dimension not in parentheses on the left of the bevel, V, J, or U groove weld symbol in cases where the effective throat is not specified or is specified elsewhere on the print indicates the size of the weld preparation only. Figure 6-16, no such dimension is needed with a square groove weld. Optional groove penetration with complete penetration is indicated when the letters CJP are shown in the tail of the reference line. No weld symbol is issued as in figure 16-7. The optional groove the weld size of a flare groove weld is considered only to the tangent point, the point where the curved surfaces meet, figure 16-8. Flare groove weld side extends only to the tangent points of the joint members. Double groove welds are dimensioned on both sides of the reference line if no general note appears on the print. Figure 16-10, if the welds differ in size, they are dimensioned as in Figure 16-11. Groove welding symbols will not include dimensions when a general note determining groove weld side appears on the print. Figure 16-12, when a break in the arrow is used with bevel and J-groove welds, the arrow points toward the member to be beveled. Groove dimensions. Many companies have established their own standards for groove weld dimensions. These standards are observed unless otherwise noted on the print. When company standards for groove welds are not indicated, the following applies. The root opening is indicated inside the weld symbol, say Figure 16-14. The groove angle or bevel angle is specified, Figure 16-15. And the groove radii, used for the form and the shape of J or U groove welds, and root faces, the parts of the groove face within the joint root, are shown by cross-section, detail, or other means with a reference on the welding symbol. See Figure 16-16. Surface, finish, and contour of groove welds. The buildup of a groove weld above the surface of the base material is called reinforcement. Sometimes the welding symbol specifies that the reinforcement be minimized or removed. Groove welds to be made approximately flush, but not generally finished flush mechanically, are specified by a flush contour symbol. This symbol is placed above the weld symbol as in Figure 16-17. Groove welds to be made flush by mechanical means are specified with a flush contour symbol and the method of making the weld flush. Figure 16-18. Groove welds to be finished mechanically with a convex contour are specified by a convex contour symbol, with the method of the finishing of the weld to a convex contour is also given in Figure 16-19. Melt-through, back, and backing welds. The melt-through, back, and backing weld symbols show that a melt-through to the other side, bead-type back or backing weld is needed with a single groove weld. Points to remember include: a back weld is made after the groove weld. A backing weld is made before the groove weld. A melt-through is a visible reinforcement produced in a groove weld from one side. A note states whether a back or backing weld is to be made. This note is placed in the tail of the welding symbol. Figure 16-20, as shown, a back or backing weld symbol is located on the side of the reference line that is opposite the groove weld symbol. A flush contour symbol added to the back or backing weld symbol indicates the weld should be approximately flush with the base metal. Figure 16-21. If the back or backing weld is to be made flush by mechanical means, the method of making the weld flush is added to the flush contour symbol. Figure 16-22. When a back or backing weld is to be finished to a convex contour by mechanical means, a convex contour symbol is finish symbol are added to the weld symbol. With the exception of height, which is optional, no other back or backing weld dimensions are shown with the weld symbol. Figure 16-23. If other dimensions are required, they are shown on the drawing. A melt-through weld assures full joint penetration. The melt-through weld symbol is similar to the back or backing weld symbol, with the bead filled in as shown in Figure 16-24. A dimension to the left of the weld symbol specifies the amount of melt-through. Backing, joint spacers, and runoff weld tabs. Backing is material placed against the backside of the joint to withstand molten weld metal, as shown in Figure 16-25. It is employed when full penetration groove welds are required and welding can only be done from one side. Backing is thoroughly penetrated by the weld and usually left in place. Joint spacers are metal parts inserted into the joint root as backing and to maintain the root opening during welding. Figure 1626. Joint spacers are sometimes used especially if the weld is in thick material and the minimum possible V angle is specified. In such welds, the root must be gouged out completely, including the spacer bar, before the second side of the groove is welded. Runoff weld tabs provide an extension of the groove beyond the pieces being joined when a full-length groove weld is specified. Figure 1627. Runoff tabs provide a place to strike the arc and material at the end of the weld to eliminate the weld crater. The angle or contour of the runoff weld tab must be identical to that of the groove. Since welding symbols give no identification of the backing, spacer, or extension bar requirements, note that unless covered by reference to AWS pre-qualified joints or fabricator standards, special sketches of the weld profile are provided. Flare groove welds. Flare groove welds are used to join round or formed metal parts. The groove that is formed when curved spaces are placed together does not have straight sides on one or both members. Two round steel bars laid side by side, such as reinforcing rods, have sides that are curved. The joint that is formed does not have the straight sides like a V groove weld. Figure 16-28 shows an example of a flared V groove weld. Either two round parts members or two formed parts members can be used to form the V groove. The symbol for the flared V groove weld can be placed on a single side, or the symbol can be indicated that the weld should be made on both sides. The depth dimension for the flare V groove weld is given as the distance from the top of the member to the point of tangency where it touches the other member or part. Figure 16-29 shows a dimension of 0.31 to the point of tangency and a weld size of 0.25. Notice that the weld size is placed in parentheses. The weld size is the distance from the surface of the part to the root of the weld. For round parts, the first dimension is the radius of the round part. Figure 16-28 shows the round bar has a radius of 1 and the weld size of 0.75. If only one part is round or formed, then the formed part and the straight part from the flared bevel groove weld. Figure 16-30 shows a formed part welded to a straight part. The dimensions used to describe a flared bevel groove weld have the same meaning as those for the flared V groove weld. The first dimension indicates the distance from the top of the part to the point of the tangency, and the second dimension indicates the size of the weld. Notice the first dimension for the round parts indicates the radius of the round part. See figure 1631. Combination weld symbols. Combination weld symbols are used when other types of welds are required in addition to the groove welds. Figure 16-32 shows a flared bevel groove weld with two fillet welds. The weld symbols specify a fillet weld over the flared groove weld on the arrow side, the fillet weld on the other side. The dimensions of the combination symbol are applied in the same manner as those used for the flare groove weld symbol and the fillet weld symbol.